Akẹ́ni kankan wa akíwa àkó àtàárọ̀ akẹ́ni kankan wa pé àkó ojúmọ́ àkó àárọ̀ ẹ káàárọ̀ ẹ káàsán ẹ̀dẹ̀ kálẹ́ gbogbo kíbi tẹ́ bá ti ń wò mí bóyá níbí ni bóyá lókè òkun ni tó ń wo fídíò mi mo kí ẹnì kankan wa pé ẹ káàárọ̀ o. Ohun tí a fẹ́ yànnàná báyìí lónìí ó ní pé a fẹ́ lọ sí magnetic field òun la fẹ́ lọ. Kí ni mo ní wá fẹ́ lọ magnetic field là ń lọ báyìí o. A fẹ́ wo n tí wọ́n ń pè ní magnetic field, àwọn èròjà wo òun ló bá magnetic field lọ, ibẹ̀ náà la fẹ́ gbìyànjú. Àmọ́ kí n tó máa lọ, kí n tó bẹ̀rẹ̀ solution báyìí, gbìyànjú kó like ẹ o, gbìyànjú kó share rẹ̀, kó sì gbìyànjú kó bá mi subscribe sí channel mi. Kí ni channel tí mò ń sọ? Physics and Math Dismantle. Lọ́wọ́ lórí YouTube kó dẹ̀ máa bá mi gbìyànjú kó download àwọn fídíò yìí kí wọ́n náà lè bá a dá. Onílágbára Ọlọ́run ìmọ̀dún ní màmọ́lù Ọlọ́run bá a dúpẹ́ fún. Àfàtìkó kí àwọn ọmọ lẹ́yìn àfàtìkó kí àwọn mùsùlùmí tó wọ́n kú ìtẹ́nu wọ́n sì kú ìmọ̀ra ọdún Ọlọ́run yóò jẹ́ kẹ́mi gbogbo wọ́n la òtún yìí já Ọlọ́run sì gbà á lẹ́sìn fún wa. Àtàwọn ọmọ lẹ́yìn Christian náà àti gbogbo wọn pẹ̀lú lẹ́ǹtì táwọn náà ń gbà lọ́wọ́lọ́wọ́ àgbẹ̀ Ọlọ́run gbà lẹ́sìn fún ẹnìkan. A tún kí gbogbo èèyàn pátápátá yẹn ti ń bẹ lágbàńlá ayé. Ẹ ṣé o tẹ́ ń wo fídíò wa o, ẹ sì ṣe gbogbo ẹ̀yin student mi tẹ́ ń like ẹ lọ́tún lọ́sì ìpín lágbára Ọlọ́run dáadáa ló mọ̀ like ẹ̀yin náà. Ẹ̀yin tẹ́ ẹ ti fẹ́ ṣe exam lágbára títóbi tọ́lọ́run Ọlọ́run lálùbáríkà títóbi rẹ̀ pé kò sẹ́ni tó tóbi tọ́lọ́run Ọlọ́run ó jẹ́ kẹ́ni kankan yín ọgbà máàkì ìdùnnú tí ó fún yín admission. Àwọn tó fẹ́ ṣe wàhálà kìíní ẹ paasi láyọ̀ àtàláfíà, ẹni tí ó ṣe mẹ́kọ̀ọ́ yín ló paasi o, gbogbo àpáta Ọlọ́run jẹ́ ká paasi. Ó yá ẹ̀dá gbìyànjú ẹ̀dá jọ pápápá ká má bàa pẹ́ lórí ẹ̀. Now mo ní magnetic field la fẹ́ lọ. Kí là ń pè magnetic field? Ó ní a field whereby we experience magnetic force. That's all. Òun ò lè jù báyìí. That is what they call magnetic field. Irú àwọn example wo kí la lè rí níta tó lè súnmọ́ wa bíi pé a lè pè ní magnetic field. Wo speaker tẹ̀ fi máa ń gbọ́rọ̀ yẹn, speaker tí máa ń ti gbúgbúgbú yẹn, magnet wà nínú ẹ̀, a lè pa àwọn yẹn náà ní magnetic field. Ó yá ẹ̀jẹ̀ àlọ́ pápápá ẹ̀jẹ̀ nǹkan question yẹn kájọ. A conductor of length 20 meter. Kí náà ń pè ní conductor? Wáyà náà ti ń bẹ́ẹ̀ lè rẹ̀ yẹn kí náà ń pè ní conductor. Or o lè pé irin o lè jẹ́ conductor. Carries a current of 2 to 0.24 ampere. While kept in a magnetic field of magnetic flux of 0.12 Tesla. Capital T yẹn Tesla ni wọ́n ń pè. Find the maximum force acting on it. Gbogbo àwọn nǹkan tán fún wa kọ́kọ́ paramítà rẹ̀ jáde náà kó tó mọ owó fọ́múlà tó lò. Kí ni wọ́n fún wa lákọ̀ọ́kọ́? Length of 20 meter ajẹ́pọ̀ ní L equals to 20 meter òtí ní. Carry a current ajẹ́pẹ́ o ní I inú máa represent current. Symbol current ní tàbá ti ń calculate I ni ó represent ẹ̀ ó jẹ́ 0.24 ampere. Tí wọ́n bá dákọ̀ current rẹ̀ má ti dákọ̀ ampere ń bẹ̀ ó ti mọ̀ pò ní. Wọ́n wá lóní magnetic field of magnetic flux of, that is magnetic flux yẹn òun ló máa represent pẹ̀lú capital B under magnetic field, ìyẹn là ń pè ní 0.12 Tesla. Tesla ó ní ẹni tí ó fún wa, that is Tesla lórúkọ ẹni tí ó pòpàǹdì lọ yẹn òun ló fà láti ní 0.12 Tesla ni wọ́n ń pè jọ́ta náà. Tó bá tún fẹ́ mọ unit mi nínú fídíò mi tí máa bá ṣe tòwó tó ní unit mi eléyìí ló ń sọ pé fundamental kẹ́ni o òun ló ń fún wa pé it is a fundamental quantity like that. Irú àwọn fundamental quantity kan tá a tún níní òtẹ̀nàsán tí a mọ̀ sí òun bọ̀ tá a bá tún fẹ́ gbìyànjú tá a bá tún fẹ́ wò òun náà ni ó máa ń jẹ́ flux is equal to B all over A. Má tún débẹ̀ yẹn àwọn àtàlàyé fọ́nù transformer eléyìí lákọ̀ọ́kọ́. Nígbà tí mo ti wá ní tán fún mi wọ́n wá ní kí n lọ calculate maximum force acting on it. Gbogbo force tí máa ń ṣẹlẹ̀ nínú generator tí máa ń ṣẹlẹ̀ nínú tá a bá ti wind nǹkan ìrántí yàtọ̀ tí transformer o, force tí máa ń ṣẹlẹ̀ ń bẹ̀ máa fún ọ ní fọ́múlà wọn nísinsìnyí. Irú eléyìí tán wọ́n wá fún ọ yìí, maximum force tí wọ́n fún ọ níbẹ̀ ò ní pé F is going to be equals to BIL. It's equal to BIL, fọ́múlà tó lónìí. Kí ni B? Magnetic flux density. Kí ni I? Current. And then kí ni L? That is the length of a conductor. Ó yí pé kò le. Fọ́múlà tó ọ̀rá lò nìyẹn tó bá ti wá rírun nǹkan báyìí tá máa ti fún fọ́múlà ẹ̀ nìyẹn. Ṣé pé kò lè tó kó yí rárá gẹ́gẹ́ bí àṣà pàdé mi kan tó máa ń fọ́lò ní orí Facebook. Ó yá ní pápápá tí ò le rárá. Maximum force F maximum is equal to Tesla kí wọ́n ló jẹ́ is 0.12 multiplied by height is 0.24 multiplied by that is 20 meter. Gbogbo ṣe rọ̀ tó. Then wà ní calculator that is over 100 multiplied by 24 over 100 multiplied by 20 over 1 àbí. Therefore èyí ó máa jẹ́ 20 here 1 20 here 5 àbí. Then 2 here 50 2 here 12 2 here 25 2 here 6 àbí kò sí tó lọ mọ́ nínú wọn. Ó fi 6 times ilé ó fún ẹ ní 72 all over 5 times this one ó fún ẹ ní 125 that is Newton. Ṣíkè náà kò bá kádàrá tiẹ̀ lọ kò ṣe létò kò rí ro rárá ánsà rẹ nìyẹn bàbá parí. O ti rí eléyìí bó ṣe lọ yìí. Now kí o tó bá tó rí ẹlẹ́ẹ̀kejì fún ẹ kó tún ẹlẹ́ẹ̀kejì bó wọn ṣe lọ. A straight line wire 20 centimeter wọ́n gbàgbé o gẹ́gẹ́ bí mo ṣe ṣàlàyé fún ọ nínú ibi tí a ti ń bọ̀ yìí wọ́n gbàgbé o. A straight line wire o ti rí ní tẹ́lẹ̀ sọ 20 centimeter ní kọ́kọ́kọ́ lẹ̀ that is 20 centimeter. Dẹ̀ràn tí wípé gbogbo parameters pátápátá yẹn wọ́n wà ní SI unit. Ilé ọ̀nà jẹ́ 20 all over 100 simply means that you are getting 0.2 meter. Wọ́n jù lè kò lè rárá. Now carry a current kí ni wọ́n pe current tiẹ̀ I is equal to 6 ampere. Òun kí n lọ tiẹ̀ nìyẹn o. It's in a uniform field of 0.8 Tesla. Mo ti ń tọ́ bá ti ń gbọ́ Tesla yẹn capital T òun là ń pè ní kíni o magnetic flux density. A jẹ́ pé B rẹ is equal to 0.8 Tesla. Wọ́n wá bí wá léèrè pé what is the force on the wire when it is at 30 degree to the field? Nínú generator pé a tó wọ̀ bá ti rí. Therefore armature ó máa ń rotate to an angle. Tó bá ti wà ní 0 degree maximum nìyẹn. Tó bá ti wà 90 degree ó ń gbéra díẹ̀díẹ̀ nìyẹn. Ó lè wà 90 ó lè wà 45 ó lè wà ní 0 ó sì lè wà ní 360 degree. Ó ti kò sí tí ó lè wà 180 degree. Bó ṣe lọ ti ẹ̀yẹn. Wọ́n tán wá fún wa láńgù bí àjẹpá ní títà is equal to 30 degree. Fọ́múlà wo wá lóòlò. Fọ́ọ̀sì náà wọ́n tó sọ ń bí wọ́n tẹ̀lé ṣàlàyé fún ọ lákọ̀ọ́kọ́ ń bí wípé fọ́ọ̀sì wa is FBI. Níbi ò ti níyẹn náà ọkàn tó fọgbọ́n mú náà ni pé F equals to BIL sin theta tó wò bó ṣe rí. Ògbó náà ṣe rí nùyí náà. Therefore látàbálà B wà kàn rí pé òun náà tún jẹ́ Tesla wá jẹ́ 8/10 times kí ni current wa 6 times kí ni length wa 2/10 multiplied by what is our sin theta? Sin 30 degree. Àtúntẹ̀síwájú ń bẹ̀ yẹn 8/10 multiplied by 12/10 multiplied by sin 30 is equal to 1/2. Tó bá mọ̀ mathematics dáadáa ó ti yẹ special angle nìyẹn. Now lábàlá kó má bàa pẹ́ a ní 2 here 1 2 here 6 àbí 2 here 5 2 here 3 2 here 5 2 here 4. Therefore you have 4 times 3 that is 12 all over 25. Therefore our force equals to 12/25 Newton. O lè tẹ̀síwájú tó bá gbìyànjú tí wọ́n náà bá ní pé kó wò pé what is it in term of decimal. You can still get it in term of decimal. You can use calculator to get it. So far it is down. You can make your answer this way. You can make your answer this way. Ó di mélòó? Ó di méjì. Kò lé tó kò rí o rárá. Àníṣe bá a ti ń bá lọ yìí. Mo ní tí n bá fi bó bá fi lè mọ tí mo kọ sójú bọ́ọ̀dù yìí o ò ní ṣòro mọ́. Kò sí ṣòro kankan fún ọmọ nínú ibi tí o ti fẹ́ ṣe ń tọ́ fẹ́ ṣe. Kò sí ṣòro o. Àní bó ti ń bá lọ iṣẹ́ èmi mọ̀ pé ó sì ṣòro kankan fún ọ àyàfi tí o bá fọkàn sí intanṣe ìlókù. Now mo fẹ́ bọ́ torí ẹlẹ́ẹ̀kẹta sọ fún wa àtúnbọ̀ torí ẹlẹ́ẹ̀kẹta yẹn kò kà nínú ẹ̀. Ó náà tó tẹ̀síwájú ó ní vertical rectangle coil of a side eléyìí ti sọ jẹ́ oyé wa rectangle òun lòun tún jẹ́ o wọ́n tún fẹ́ mú nǹkan mi wà fún un tó ti ń tẹ́lẹ̀ jẹ́ FBI sin theta yàtọ̀ òun tẹ́lẹ̀ inú jẹ èyí fún wa rectangle side adẹ̀túmọ̀ pé tá a bá ti ní rectangle àti ní side méjì a ní length and what and breadth nìyẹn kí ni length wa jẹ́ ó jẹ́ 8 centimeter a jẹ́ pé breadth wa náà jẹ́ 4 centimeter has 20 ton ó tún ní number of ton adẹ́pẹ́ wọ́n ti wé nǹkan mọ́ ìwé wọ́n ti máa ń wé ọrùn fáànù yẹn wọ́n ti ń wé bẹ́ẹ̀. Òun náà tún ní Newton, that is 20 Newton níbẹ̀ ní títí ẹ̀. Ó tẹ̀síwájú and carries a current, wọ́n ti gbé current ẹ̀ wá o, Ni equals to 2 ampere. Ó tún tẹ̀síwájú, ó ti ní interference ẹ̀ lọ. Calculate the torque. Kí là ń pè ní torque nínú generator? Torque náà force náà ni, force náà torque náà force ni ìlẹ́bẹ̀ẹ́jẹ̀. Tó bá jẹ́ pé ó ti bọ́ sínú ìgbòmí lámọ̀tọ́ wípé tí force ni àbí kí lápè, it is F, that is the torque has a relationship to be the what? Newton, that is Newton meter, because it's the force multiplied by the torque usually be like force multiplied by perpendicular distance, which is Newton per meter on its own. But on this aspect, it is the same thing as a what? As a force that generated from the what? From the magnetic field. Ẹja tẹ̀síwájú. Calculate the torque on the coil when it is placed in a uniform horizontal magnetic field of, ajẹ́ pé mo tún ti ní B nìyẹn. B is my magnetic flux, which is always be in Tesla with the parallel to the field. When we say something is parallel to the field, simply means it at 0 degree. It is at what? 0 degree. Now, when you have something like this, you can see that all parameters are many. The angle is not here. The angle is not here. You will see that the angle is not there. And at the end of the day, you will see that it is quite different to the other two questions. It is quite different to the other two questions. The next thing that you need to do is that what? Bring your torque, come. The torque is also comes in terms of F. That is Ft is equal to NA BIL. We call it what? The torque formula is going to be number. What did I call it? Number. Where N stands for the number of turns, A stands for the area, that is the shape of the armature. This one is going to be the magnetic flux density of that way, which is constant with every magnet. While this one is the current and the length is the length and the length is the shape. And L is going to be the what? Is going to be the length of the what? That is what we call a number. Had it been that we are given a theta there, it's going to be what? A number sine theta. That is what we are going to use for that one, which is normal thing, kind thing. And therefore now, for you now to get this one, it is so simple for you to get the something of that nature. Therefore, you have no problem in doing something of that. That is how we are going to solve the problem relating to something like that. That is how to solve the problem. Then we are using the formula up here, and that is the formula called Nabai. What did I call it? Nabai. That is where N stand for number of Newton, and where N stand for number of turns. N stand for number of turns. A stand for area. While I stand for the current, and as well as L stand for the what? The length of the what? That is the length of the that is the length of the what? The length of the wire. Now from here, we are looking at this. They said a vertical rectangular coil of this side and has turn and carries this of this. Therefore, you have your N is 20 multiplied by A is what? That is 8 multiplied by 4 divided by what? You know that this one is centimeter. Okay, let me have it in what? In the other way around. That is 8 over 100. That is 4 over 100. This is 0.08, 0.04. Therefore, we have 8 all over 100 times 4 over 100 multiplied by 0.2 multiplied by current. Our current is 2 ampere multiplied by the length. That length of the wire is 8 all over 100 as well. And at the end of the day, you have 20 multiplied by 32. 8 times 4 is 32 all over 1000 all over 10,000. 1 2 3 4 1 2 3 4 times 2 all over 10 multiplied by 16 all over 100. You know, I multiply this one like this, and from here, therefore this can cancel this to give us 2, and at the end of the day you can have your something like 2 here 1, 2 here 50, 2 here 1, 2 here 25, and then we can have 2 here 16, 2 here 2000, 2 here 8, 2 here 10 0 0, 2 here 4, 2 here 500, 2 here 2, 2 here 25. Therefore we can have 2 multiplied by this to be given us 32 all over 625. That is our Newton. That is our torque at this junction. That is what they call it what? That is what they call it this. Then in another case, somebody said that the torque they have to calculate. Torque simply means that in another area it means force multiplied by perpendicular what distance. So far the distance is not given. If you are getting this one to be the what your Newton, then what should be your distance here? What should be your distance to multiply with this? That's the reason why you cannot use the torque of the other side. That's why the torque here is equivalent to the what? Number. The force is equivalent to the number here. That is 32 all over 625 Newton per meter, according to Newton meter. Yes, that is the unit of a torque, is Newton meter at that junction. And that is how to solve the problem for you. Look at the 3 questions. I said there is no way that you cannot watch. There is no way that you study this one that will not be able to kó tí bó ṣe fẹ́ ṣe tó bá ti gbọ́ ohun tí mo sọ ń bí yé dáadáa, you have no problem lórí àwọn nǹkan yòókù. And you can just bring a question, you can challenge me, give me a question, I need your comment, and I need everything about you that you want to say about this. Gbogbo ohun tá a bá fẹ́ sọ lórí àwọn tá a ṣe yìí, ẹ jẹ́ kí n rí ní comment section yín, ẹ já gbìyànjú káwa náà ṣe dáadáa. Ẹ ṣé o, thank you so much. Èyí jẹ́ lórí magnetic field, àtúnbọ̀ láìpẹ́. Thank you. Kọ́lọ́run kó bá mi ṣàánú fún yín o. Ẹ má gbàgbé o, ẹ bá mi like ẹ share rẹ̀, kẹ́ ẹ dẹ̀ ṣe kí ni o, kẹ́ ẹ bá mi like kẹ́ ẹ bá mi share, kẹ́ ẹ ti subscribe. Ẹ ṣé o, thank you.